Anyway, David.
Okay, good afternoon. Good afternoon, everyone.
Good afternoon, sir.
Yeah,
Good afternoon, sir.
how you guys doing?
Good afternoon. We're fine, sir.
So it appears more students will join. We have 134 of you now. So once again, you are welcome to FBA 231 class. The old code was FBA 210. Hello? We have 158 now. So I think I can start. Okay, so the course is business mathematics. The objective of this course is actually to apply all the basic concepts that you have learned in your FBA 110 and 120 to solving basic business problems. So that means we shall be applying the concept of the sequence and series to business problems. So you should be able to relate the sequence and series lessons to financial problems. So how does the convergence, divergence relate to annuity? How does the concept of divergence or convergence are used in financial mathematics? After that, we look at the application of differential calculus to business problems. We'll also look at the application of integral calculus to differential problems, to business problems. Application of vectors and matrices, and also functions to business problems. So basically, it's about applying all that we have learned during our first semester and second semester 100 level courses, algebra and calculus, so basic business problems. So at the end of the course, students are expected to know how to apply the principles of sequence and series as it relates to financial transactions, and also apply the knowledge from differential and integral calculus to basic problems. So you should be able to also reduce any problems using functions or matrices if they are applicable. So what am I teaching you? And to apply integral calculus. So specifically, we'll be looking at total cost, variable cost, average cost, marginal cost, total revenue, marginal revenue, and average revenue. So we look at all those concepts and see how integration comes into play. So how do you find the total if you have the marginal? So if you have marginal cost, how do you get the total cost? If you have marginal revenue, how do you get the total revenue? If you have functions that you don't know the total, but you know the marginal. Also, if you have a function that gives you an idea of the average, how do you get the marginal? So we'll be looking at that in this particular topic. So it's a very simple topic, and it's an application of what we have learned earlier. In preparation for this lecture, I had sent some materials prior to this time, and I want us to confirm the receipt of those materials. Please kindly confirm the receipt of those materials.
Yes, I will receive them.
All right. So then I also shared a video and also past lecture recordings. Please, I need a confirmation of that indeed you have received them.
Yes, I will receive them.
Okay. So more material can still be shared. Everything depends on if you made requests, I will grant them. So please feel free to always express your mind, make requests, and there's an area that you feel I needed to clarify, please feel free to do that. So integration, this is not the first time we are getting to introduce to the concept of integration. I'm sure we can still recollect the differential equation, the YDS, that if you have a function x squared, for instance, and you are differentiating that x squared with respect to x, remember what you will do, that generally you will use the power to multiply that function. So in this case, the power is 2. You use it to multiply it, so it becomes 2x squared, and then you now reduce the power by 1. So you now have 2x to the power of 2 minus 1. So the differential of 2x of x squared with respect to it becomes 2x. Now, what if we are to reverse that procedure? The reverse of the differential process is the integration. So integration is a reverse process for differentiation. And what we have on the screen is a brief summary of basic integral of some functions. So the first one to the left, if you have a constant, C, and you are integrating that, now what you will do is that you multiply that function, that constant, by x. That is, if you are integrating with respect to x, you multiply the constant by x, and then you add an arbitrary constant to it. Remember, you are reversing the function. So the first one, the constant here is 1. Now you are integrating 1 with respect to x. The 1 need not to be written. And from what we already know, is that if you integrate 1 with respect to it, gives you x plus the arbitrary constant c. If we have further information, the arbitrary constant c can easily be derived, but easily be computed with extra information. Now, what you have on the right of the table, the very top, you are integrating a constant a with respect to x. That the integral is ax Let's see. If we have been taught at the 100 level, FBA 120, and you have also done it at the secondary school level if you did further mathematics. So also, if you are integrating a function to power 1, what the integral says is that you will increase the power by 1 and then divide the new function by the new power. So I have x to the power 1. X to the power 1 needed to be integrated with respect to x. So the power of x is 1. So the procedure says increase the power of x by 1. So that means the new power will now be 1 plus 1. So I've increased it by 1. So I have a new function, x to the power of 2. So to complete the integration process, I will divide by the new power, 2. Then at the end of the day, I add my arbitrary constant c to it. And we have other standard integral as presented on the table. So why are we adding the arbitrary constant c? This because of the integration. The integration that we are executing. This is known as indefinite integral because you are not integrating without any limits. But if you're integrating within a bound, within a limit, then it's easier for one to get the exact function or the exact value as being investigated. So these are basic results of standard integral. And it is expected that at this level, we know how these results are derived. So further standard results are also presented. But what are the properties of integration? These properties actually guide the standard integral as being presented in the subsequent, in the earlier tables, in the earlier pages. You can see that if you have a constant a and you are integrating, if the constant is multiplying a function, what the procedure is proposing is that factorize it. So you can see that a is multiplying the function f of x. So if you take the a out as a factor, then you go ahead and integrate your function. After the integration, then you multiply by that constant a. You have your integration concluded. You could also leave the a as it is. Use it to multiply all the terms in the function, and then you integrate each term before combining the results. You are still okay. But it's a smarter move for you to have just factorize the a and then do your integration. The second property is that if you have two functions, f of x and g of x, and you want to integrate their addition or their subtraction, You could add, and then the resulting addition, you integrate if you are dealing with addition. If it is subtraction, you could subtract, and whatever you arrive at, you integrate. That's one approach of handling it. The other approach is that you take the function on their own and then do your integration one after the other. So if there are two functions, integrate, function 1, integrate, function 2, and then you add up the two integrals, and that gives you the resulting integration. Or you could just add function 1 to function 2, and whatever you get, you then integrate. That's another approach. So that's what the second property is talking about, is that you could actually do the integration separately and then add to get your final result, or you could add before integration is done. So we have looked at two properties of integration. Remember that these properties have already been discussed at the 120 level. Now let's look at some problems that will require us to apply the two properties. So we have to integrate 1 plus x times 1 plus 2x. So you will agree with me that we have two functions, 1 plus x and 1 plus 2x. So these two functions are multiplying each other. So what you need to do before applying the integration is that you expand the function. You expand the function. So someone is saying, as you use the cursor, I am deliberately slow so that you will understand it as being displayed. So the approach I'm using is deliberate so that everybody understands. There is no other example on the screen. So you will see it. You will see it that I have just one example being displayed. So I said I have two functions. The first function is 1 plus x. The second function is 1 plus 2x. And I'm to integrate. The symbol here is the sign of integration. So I'm to integrate the product of two functions with respect to x. So before you can do the integration, it is advisable that you expand the product of the two functions, and then you now integrate the resulting expansion. So if you integrate 1 plus x multiplied by 1 plus 2x, you will arrive at 2x squared plus 3x plus 1. 2x squared plus 3x plus 1. So that is what we will now integrate. Now I can see further down that by the time you apply the integral function to it, we will now make use of the second property of integration. The second properties of integration. Have a look at it as displayed. You can see that if I have function g of x and f of x, they are multiplying each other. Remember, I said that you could do the addition if it is possible to combine them. And whatever you arrive at, you integrate. Or integrate the function independently. And then whatever you have after the integration, you combine accordingly. Either it is minus or plus. So let's go back to the very first example. Please feel free to raise your hand. We are not in a hurry here. My job here is to make sure that you understand it. Okay, so we are not in a hurry. So if you have any challenge, just call my attention. Okay, now remember that we want to integrate the product of two functions. We are integrating the products of these two functions. What are the functions? 1 plus x and 1 plus 2x. So their product after the expansion, the product will yield 2x squared plus 3x plus 1. That's the product. Now we bring the integral function. We bring in the integral function now. So we can now rewrite our original question. We will rewrite the original question as the integral of, this is the expansion, 2x squared plus 3x plus 1. Now, if I now apply the second property, so which means that each of the functions will be integrated. So I have 2x squared. I'll put the integral sign there. I have 3x, put the integral sign there. And 1, the x, I put the integral sign there. So 2x squared will be integrated. How will you integrate 2x squared? Look at property number 1. Let me quickly scroll up to property number 1. What does property number 1 say? It says, if there's a constant a that is multiplying a function, that it is advisable that you factor out that constant and then do your integration. After the integration, you bring the constant back, and then you have your final result. So we're going to apply that here. 2x squared. The f of x there is x squared. What is a? A is the 2. So the 2 comes out, and then I have the 2 integral x squared dx. The same thing applies to 3x. 3x. The constant there is a. Sorry, is 3. The 3 comes out, and then I integrate my x dx. And then lastly, I have my 1. Okay? So if I apply the function, the standard integral has been displayed on the table, then I have my results as displayed. Okay, so let's look at another question. Remember, we have not started application. This is just a review of what you have learned earlier. So it becomes easier for us to recall during the application stage rather than struggling to start learning how to do the integration. Now let's look at the second example here. We are to integrate 1 over x squared minus 1 over x cubed with respect to x. 1 over x squared minus 1 over x cubed with respect to x. From the knowledge of our indices, we know we can rewrite our 1 over x squared as x to the power of minus 2. So we can also write or rewrite our 1 over x to as x to the power of minus 3. So if we rewrite these two terms, so we are going to have the integral of x to the power of minus 2 minus x to the power of minus 3. And then you integrate them independently. The power of x to the power of minus 2 is minus 2. The power of x to the power of minus 3 is minus 3. And then perform the integration by adding 1 to the power and then divide the new function now by the new power. So you do that for all the terms, and then we are good to go. So, and that is why we have x to the power of minus 2. If you add 1 to minus 2, you are going to get minus 1. So the new power is minus 1. We use that to divide. The same applies to x to the power of minus 3. If you add 1 to it, you're going to have x to the power of minus 2. And then the new power is minus 2, which you use to divide the term. So at the end of the day, if you simplify, you will end up getting minus 1 over x plus 1 over 2x squared. And then, of course, we need to add the arbitrary constant c. So, more examples. So we have two functions again. So the second property applies. We are integrating the square root of x plus the cube root of x. So we shall rewrite those two terms using the law of indices. So the square root of x is the same as x to the power of half. The cube root of x is the same as x to the power of 1 all over 3. So you apply the same integration method, increase the power by 1, and then use it to divide the new function. So we have two powers there. The first one is 1 over 2, and the second one is 1 over 3. So if you add 1 to each of them, and then you use the new the addition to divide the term, we shall have the result as being displayed. These are not difficult in any way. It's just a way of revising what we did during the 120. More problems solved as displayed. So I have to integrate x plus root x all to the power of 2. X plus root x all to the power of 2. So this requires expansion because x plus root x to the power of 2 is the same as x plus root x times x plus root x, and that requires expansion. So if you multiply that by itself, you will arrive at x squared plus 2x to the power of 3 over 2 plus x squared plus 2x to the power of 3 over 2 plus x. That's what we arrive at. So again, property number 2 will apply because you have two functions adding to each other. So you are going to integrate each of the functions and then combine the result at the end of the day. And that's what was done as being displayed here. I'm sure you can see it. So we are to integrate x squared plus 2x to the power of 3 over 2 plus x. So if you bring in the integral term, the integral function, you shall have the integral of x squared dx. You shall have 2 times the integral of x to the power of 3 over 2. Then you shall have integral of x dx. It's very straightforward. So each of the terms will now be integrated using the basic method of integration. And then you have your result. Again, we add the arbitrary constant c because we are currently executing indefinite integral. More problems as displayed. So we have the integral of the cube root of x plus exponential 3. The cube root of x plus exponential 3. Exponential 3 is a constant because the Euler's function has a definite figure. Is that not it? E to the power of 1, you press your calculator, it has, you know, it's a figure, it's a constant. So even if you raise it to the power of 3, it's still a constant. It has no x in it. It is when you have e to the power of x, that's when it becomes a function. So it's still a constant. So, and that same rule, apply that if you have a as a constant, if you integrate a, you end up getting ax plus c. So the same thing applies here. So we have two terms there. We have a constant and a function. This is the constant. E to the power of 3 is the constant. And then you have a function, which is x to the power of 1 all over 3. So integrate the two of them separately. And of course, you arrive at the answer has been indicated here. It's straightforward, and it is deliberate that I gave more than enough examples. It's just for you to be able to relate, with your integration and quickly refresh yourself. And let's look at the application. Let's look at the application. I have some summary here. So we'll look at those summaries, take them one after the other, and then we start the application. So I'm sure your class governor told you that we won't be able to do more than 1 hour today. I quickly, took advantage of this time because the lecturer that was going to take you is not available. So we have a departmental meeting at 1 o'clock. So I told him that I can do the introduction within 1 hour. And then we'll now fix an extra class where application will be discussed in detail. So what I've given you so far is a preliminary review of some of the integration techniques that you have been taught. Now let's look at the itemized application, just a general overview. Integration can be used to calculate the total sale. So, as you can see at the top of the table, before you have the bullets, that if you have a function, f of t, where the f of t represents the marginal sale at time t, that you could get the total sale by integrating. Okay, the total sale at any given time by integrating from 0 to a given upper limit. Okay, so you can also use integration in elasticity of demand. Integration is also very applicable in determining total inventory carrying cost, as presented on the screen. In the area of annuity, integration is very, very useful. In the area of annuity, integration is very, very useful. So if you look at cost function, there's a relationship between the total cost and marginal cost. So if you have the marginal cost, to get the total cost, all you need to do is to integrate. So that is how integration can be deployed in the area of the cost function. Same for revenue. If you have marginal revenue, integration of the marginal revenue will lead you to the total revenue. Of course, if you are able to get the total revenue and the total cost, the difference will go into the profit function. So integration is very, very useful in determining your profit function. Of course, your profit function is the difference between marginal revenue and the marginal cost. Sorry, total revenue and total cost. So, and then you know that if you are able to get the marginal revenue, you know you can integrate to get the total revenue. Same for cost. If you have information about the marginal cost, you can easily get the total cost. Integration also comes in consumer surplus and producer surplus. So the integration that you're looking at is very, very applicable. Okay. So we'll take this few definition and see if you can take just one more application before I start preparing for my meeting. So we all know that the total cost of production is made up of variable cost and fixed cost. The variable costs are those that changes as the number of units increases or reduces, while the fixed cost, the cost that you incur for having the system in place. So whether you produce or not, you will incur it. Imagine you have a factory that is producing books. The factory produces books. Whether the factory is producing or not, there are some costs that the factory will incur. The factory would employ a security guard, right? And whether the factory produces or not, the security guy will have to be paid. If there's a ground rent that is being charged on the factory, so whether the factory produces or not, that ground rent will need to be paid. And there are so many other costs that are fixed, irrespective of whether the factory is producing or not. So all of those will come under the fixed cost. But the variable cost, not to produce a book, you need raw material. So if you are producing 100 books, the quantity of material needed will not be as much as the material required for 2,000 books. So you will notice that the quantity of books being produced will determine the raw material that will be consumed. And that easily translates to cost as well. So all of those will come under the variable cost. So you have your total cost as a combination of fixed cost and your variable cost. So these are part of the explanation and so on. The same has to do with your demand, your profit, your break-even point. So all those are just preliminary relationships that you need to understand between some of the variables. Now let's look at this example 1. And after the example 1, like I said earlier, you would please excuse me to join my departmental meeting. But before we meet again, I will just advise you to go through the other videos that I've prepared. I mean, past lecture, and then there's a video on past question and answer that I also shared. So please go through them so that by the time we meet in the next class, it will be more interactive and it will be more of addressing your questions. So now let's look at this example 1. It says that the marginal cost function of manufacturing X shoes is as given: 6 plus 10x minus 2x squared. And then there's an extra information. It says the cost of producing a pair of shoe is 12 naira. So we have to find the total and average cost function. Total and average cost function. Remember that earlier I'd already given us the relationship between marginal and total. So I've said that if you are given marginal, that to get the total, all you need to do is to integrate. So when you integrate the marginal, you get the total. So the marginal function is given as 6 plus 10x minus 6x squared. 6 plus 10x minus 6x squared. So that means we just need to integrate that. So we are making use of the property 2 of our integration. Remember that property 2? When you have 2 or more functions adding or subtracting from each other. That if you are to integrate the addition or the subtraction, all you need to do is to take each of the terms and then integrate them. So whatever you get, you add up. So you can see that we have three terms there, three functions. 6 is one, 10x is second one, and then minus 6x squared is the third one. So we are going to integrate each of them with respect to x. So if you integrate 6, 6 is a constant. So the integral will just require us to join x to it. So it will be 6x. If you integrate 10x, the integral will be 10x squared all over 2. Where is the 2 coming from? Remember that 10x means that our x is to power 1. So if we increase that x power by 1, so we're going to have 10x to power 1 plus 1. Then you now divide by that 1 plus 1. So that is how we arrived at 5x squared. The same applies to minus 6x squared. So if you increase the power, it becomes 6x to power of 3. And then you use that to divide. So you end up getting minus 2x to power of 3. And of course, because we are not integrating under definite limit, we are going to add our constant c. For this time, we are adding simply called the constant k. So that will be the integral as given as equation 1. But we have further information. So we're told that a pair of shoes is 12. Is that not it? A pair of shoes is 12. That means when x equals to 2, c is 12. That's the extra information we were given in the question. When x equals to 2, c is 12. That's the question. So which means that we are going to plug in that 2 in the function that we arrived at. That will make us to calculate the arbitrary constant. So if you plug that value in, when x equals to 2, plug in 2 here, the whole cost function equals to 12. So we'll be able to solve for k. So that means the cost function now can now be written without the use of k. So someone is asking a question, where is the 2 coming from? Okay, it's in the question. Now let's go back to the question. Now look at the question. It says the cost of producing a pair of shoes is 12. So we all know that a pair means 2. Abi?
Right.
So that's where the 2 is coming from. Okay, that's where the 2 is coming from. So if you plug them in, you'll be able to get the cost function as this. C equals 6x squared plus 5x, 6x plus 5x squared minus 2x cubed minus 4. That is how you arrived at the total cost function. Now, to get the average cost function, the average cost will be total cost divided by the number of units. Divided by the number of units. X is the number of units. So if we divide the total is 6x squared plus 6x plus 5x squared minus 2x cubed minus 4. That is the total. So we're not going to divide that total by the number of units, x. So if you divide by x, whatever you arrive at here is our average cost. That is the average cost. So that is where we will stop, today. I really want to take it slowly but surely. So what have we done? I just quickly reviewed some of the integration technique with you. I didn't review the methods of integration. I reviewed those that are relevant to the application of business. So we went through some of the functions, and then I also listed out where integration can be applicable in business. So I listed them out, and then I told us how integration can assist us to link marginal to total, how it can lead us to get the total revenue, total cost, and total profit if we have information about the marginal. So after that, we listed out some basic definitions: cost function, marginal cost, variable cost, demand, supply, and the likes. After which I took only one example. We have only looked at example one. And the example one shows how you can use marginal cost function to get the total cost function and also get the average cost function. So, ladies and gentlemen, we'll stop there for today. And then I hope we meet very soon so that we can conclude our topic. So I have a series of past questions that you can use in preparing yourself for the exams. Please reach out to Dr. Adejola so that we can compile some of those questions for you and start getting ready for our tests and also the exam. The test will be done online. We shall share a link with you on an agreed date, but we will give you a time bound under which you do your test. And then immediately your results will be made available so that you already know, what you have been, what you have got, and then start preparing for the exam. It is very likely that we shall make the test over 40, so that as many students as possible can take advantage. So on that note, I'll be willing to take your questions if you have any. Do you have questions? All right. So if there are no questions,
Sir,
okay.
good afternoon, sir.
Good afternoon. Yeah, go ahead.
The 12 plus 20 minus 16 plus k. Please, I'm just doing in the class. Where did the 20 minus 16 comes from?
Okay. 20
Is that 20
minus 2.
Yes, sir.
20 minus 2.
Minus 16.
Okay. So x is 2, Abi? Now let's plug
Yes,
in.
sir.
Let's plug in this equation 1. Let's plug in 2. So when x equals to 2, 6 times 2, 12.
Okay. Yes.
Then when x equals to 2, x squared here is 4, right?
Yes, sir.
4 times 5, 20. So when x
20.
equals to 2, x to the power of 3 here is 8, right?
Yes, sir.
8
8
times 2, 16.
Okay.
So that's where we got them from.
Yes, sir.
All right.
Thank you so much, sir.
So, ladies and gentlemen, so I see you some other time. Bye-bye.